is that like basically as you're going through this, you're doing a little bit of planning ahead. Now, so basically you want to look to change everything into cosine and sine if you can. Now this isn't always the case, so I'm just going to say like that should be your first try is can I change everything to sine and cosine? So I already have a cosine, and then with tangent, don't just like put it into the first form you see on your sheet. Look to see, can I use sine and cosine? Because I already have a cosine. So being like smart about what you're already working with is important here. So like kind of being a little strategic as you go through this. Again, this is a very easy one to start with, I think. Not trying to bust your bubble if you like were really excited that it went so well. But just understand that this is kind of, again, baby steps as we're working through this. So cosine, I'm going to leave. It's being multiplied by tangent. Now you could switch tangent to 1 over cotangent. However, I don't have cotangent in here, so that means you just brought a whole nother trig function in that's not in this problem. I'd prefer to write tangent as what over what? Sine over cosine. Guys, you really need to have other stuff put away right now. If you guys are working on something else, that's not going to be good. So now we have a fraction, and so we can cancel. There's a cosine on the top and the bottom, so we can switch this over to sine. Now I'm going to warn you guys, the next one takes like a big jump in terms of like difficulty. So it's not a very easy one, but again, it tells you what it's going to end up looking like. And again, that's kind of what we're going to talk about tomorrow, is that they're going to say, I want this side to equal this other side of the equation, and we're going to try to get those to match. And so getting used to that is what we're going to work towards. But again, they're giving us what it equals. I want to start what's on the left. I want it to end up to look like what's on the right. Now again, knowing where I'm headed, like being kind of wise about our plan here, is I'm heading towards where I have 2 cosines. And right now I have a cosine and I have a sine. So this says 2 cosines. If I have cosine and sine, what do you think I want to switch into the other one? Any thoughts? Where do we want to head, or where should we go with this?
Probably turn back to the tangent. No.
Okay, so you can't just choose like multiply by 2 to get that, to make it work. It's not like an equation where you can multiply each side by something. We want to manipulate this to make it look like this over here. What do you think, Sam?
Pythagorean rearrangement.
We're going to do some of the Pythagorean rearrangement kind of here. So what I'm going to suggest is this one has cosine, and down here I have just a cosine. So somehow I would like this to become cosine instead. Does that make sense? Because if it ends up as just cosine, and I have a cosine to begin with, I want it to end up being cosine. Is there any way to change sine squared of x into something with cosine? And this might be in the back of your Pythagorean, like the sheet where we wrote all those different. It is on the back side, like so the one that says 1 through 8. How can I write sine squared in a way that uses cosine? Yeah, 1 minus cosine will equal sine squared. You see that? So this I can replace with 1 minus cosine squared. So where we got that was from the second one on our sheet on the back side there. So in place of sine squared, I'm going to write 1 minus cosine squared. So again, kind of thinking ahead with this, that I can tell that going from cosine and sine to just cosine, I want to work towards that. And so kind of trying to set a game plan for that. Now this becomes an algebra problem. I'm going to distribute this in. That's -1, right? And this becomes plus cosine squared.
Oh, yeah. So we get 2 cosine.
Yeah, there's 2 of them there now. There's 1 and 1. Now, we haven't seen anything that's looked like this before, or like with cosines and sines. But essentially what this is saying is if I had x squared minus 1 plus x squared, you would call that 2x squared. This is just for treating these cosines just like it's a variable, just by itself. Yep. It should be -1, thank you. Just making sure Tara's still paying attention back there. Keeping her on short leash. You guys see why I just, it was just maybe. All right. Now, example 3 tries giving you a little bit of a clue. However, there's another clue here that I'm going to point out to you guys. Do you remember what I said yesterday about problems like these?
Like you can do the top first
And why is the top good to do first here?
because the middle
Parentheses.
Yeah, this is one of those nice conjugates. You don't have to know the name, but when I have a conjugate, like where I have the same thing with the opposite sign, I'm almost always going to tell you you're probably going to end up foiling. It probably is leading you to do something with that that's not just like just a coincidence that it's written that way. It's probably because it's going to be helpful. So anytime you see conjugates, it probably means you want to FOIL. So I'll let you start there, and I will give you guys a minute to try. So FOIL that, please. You still working, or are you ready, or?
I'm stuck while I get the first
Okay.
I'm good.
All right, so do you guys FOIL? We're okay with foiling? Okay.
Yep, got that.
Good, at least you got that. Okay. So, when I do this, I'm not even going to write the middle two terms because I know they cancel. So I know this just equals cosecant squared minus 1. So again, the cosecant and the cosecants will cancel, so I don't need to write that extra step. All right. So at this point, looking to see, is there anything I know about cosecant squared minus 1? Anytime you have like a plus or minus 1 with the squared, that's probably a clue that you want to look at your Pythagorean identities. Does anyone see what that would equal? It equals cotangent squared. And either if you can manipulate that from the front side, otherwise that specific thing is number 8 on the back side. So this is cotangent squared. Okay. That makes sense?
No, I don't get that.
Did you look at number 8 on your sheet? So cosecant squared minus 1 equals the cotangent. Alright, we're not done.
Yeah, I knew it.
And you can't just cancel the squares, you can't just cancel them because they both have a C and an O. Cancel the C and the O and we're done. Yeah, that would definitely be killing something, but I don't know what. Alright, so cotangent squared. Can I rewrite cotangent squared in a way that uses something that I already have? Yeah. Yeah, so I'm going to rewrite cotangent squared as cosine squared over sine squared. Just don't forget the squares. Now, I am making this a more complex fraction, so you might be like, why would we do that? However, we're getting ourselves closer to like what we want is we want things to cancel. Now, a fraction within a fraction, I'm going to put this over 1. The point of us doing the fraction exercises, like whenever we did that, was so that we were comfortable with dividing fractions. When I divide fractions, I multiply by the reciprocal. So I'm going to multiply by this flipped.
I'm a freaking genius.
I'm going to cancel. So I'm left with 1 over sine squared. I'm fine with this as an answer because it's a single term and it's sine. However, if you don't like the fraction, how could you write this? Yeah, the cosecant. Just don't forget the squared. I'm fine with either one, just so you guys know. Sometimes it's nice to say I know everything's in sine and cosine. However, I like things not being a fraction. I would check on it, but
Can I go check out?
please go check. Just making sure he's okay. All right. Let's do one more before we take a little break.
Are we gonna go see the kids sing?
I don't think so.
She said yes.
We weren't invited.
We don't need it. I don't think kids would be mad about watching.
John.
He's okay.
The issue is that they're distracted easily. Was he okay?
Yeah, the fans are spinning opposite ways.
That's what he was screaming about?
Yeah.
What was that?
The fans.
Turn them on.
Can't you just like turn the little switch and then go the other way?
That's
Why
what
do
you
these
think.
fans, why are they never on?
Because they're
Because
scared.
freezing in
Because
this room.
we don't, I don't know. Well, actually, in middle, when I taught summer school in the middle school, once I came back, I left the fan on all day or all night, and it had like broken off. The thing, the blade had gone flying like in the room. So they, yeah, it was yeah, and so like now I'm afraid to have it like and then it'll fly and hit like back on the head and then
No,
she won't be able to go to her. But then you could maybe be injured so that then you could go to the wrestling match whenever that is. You can get
Turn it on. Turn it on. Flip that switch.
okay.
Actually,
Freak accident.
Okay.
You're done. Okay, you're done.
All right, we're doing so this one again. I'm trying to give you some clues with our directions here. It says simplify by combining fractions and using identities. Obviously, all of these are using identities. But if I want to combine fractions on this one, I need to get common denominators, right? So, not the most easy thing to do. However, and again, that's why we did that fraction worksheet to remind you common denominators are necessary. Now, when you look at this one, careful, 1 minus sine is not equal to cosine. Do you guys see that? What's missing if we wanted it to equal cosine? It's not squared. This isn't a Pythagorean identity. So just be careful that the 1 in the sign looks like we should be able to do some sort of cosine thing with it, but you can't. So, common denominators. Not the most ideal situation here for common denominators, but it's not that bad. Should I count how many steps? 1, 2, 3. I think I have 3 or 4 steps.
That's a lot.
Okay. So, common denominator. If you can't find the common denominator, what's like kind of the fail-safe way? What can multiply it by the other one. So this one's going to get multiplied by cosine of x. If I do that to the bottom, I have to do that to the top. Okay? Over here, this one has to get multiplied by 1 minus the sine of x. It needs what the other one has. So the bottom has now become kind of this complex situation here. We'll deal with that in a little bit. The top of this one is cosine squared. And if you skip some of these steps, that's fine. I'm just going to go slowly. I think if I go too fast, you'll lose your mind.
That's disgusting.
What? Are you guys are okay with cosine times cosine is cosine squared, right? And then here, do you want to distribute that right away? Okay. So up here I have 1 sine of x, or just sine of x, minus sine squared. Now I'm going to warn you guys, notice this is being subtracted, so we have to subtract this whole top from the other part. Let's give you a minute to make sure you're okay with where we're at right now.
Wait, can you say it again? Sorry. I'm confused.
So we have to so we're subtracting these fractions, so I put parentheses around it to remember that I really have to subtract both of those from the cosine squared because of the minus sign there. Are we okay with how I went from here to here?
I guess.
Speak up if
It's
you're not.
disgusting. It's
Any
disgusting.
questions on where anything came from? Alright,
You just multiply both the denominators by each, right?
yeah, whatever the other denominator had, and then if you do that to the bottom, you have to do it to the top.
I just think it's disgusting because it is.
It is, it's ugly right now, but in a minute, it won't be so bad. So I have cosine of x, so cosine squared of x minus, because of this, sine of x. But then this one becomes what? Positive. Now the bottom just stays as it is. So you don't like subtract the bottoms or anything like that. Does anyone see something good that can happen right now? Yeah, what do you see?
Change the cosine to x is the one
Maybe I
minus
said
sine
that the
squared on the top.
So it's changed, sorry, this
Yeah.
with what?
The one
Oh, you
minus-
changed it to a 1 minus? Ooh, I didn't even think of that. I'm gonna, that works. I'm gonna show maybe a little bit quicker way. So what he's suggesting is that becomes 1 minus sine squared of x. Sorry, those of you guys on video, you don't see this.
Take the L.
I don't know. So, because then, what happens? Those cancel. That becomes the top, right?
What? No.
Does anyone see here kind of, we can kind of skip a step here. Does anyone see it? Oh my god, it's 1. It's 1. Cosine squared and sine squared is just 1 together. So John's way works, like that's fine. That didn't occur to me. And again, this is kind of showing that there's not one right, we all want to get to the same spot, but there's not only one way to get there. Sometimes there's probably a better than others. I'll tell you, sometimes when I'm doing really long problems like this, I'll lose the x's on them, That's not the end of the world as long as you put them in at the end. It's gonna be okay.
Maybe it would be something similar to this, like in the test.
This
Like
one's a
as
little
big,
bit on
like
the
as
tough. I mean, do you guys see something now we can do?
Cross out the, yeah. So just comes
So either one is fine with me, whatever you prefer, or just know that those two are the same.
Okay.
Okay, great.
Oh, no.
I put
I think it was wrong.